Assalamualaikum warahmatullahi wabarakatuh and good morning. So today we will continue our lesson with lesson 2, empirical formula and molecular formula. So our objective for this lesson is to define the terms empirical and molecular formula. That is the first. That is the first objective. So the second objective is to determine empirical and molecular formula from mass composition and combustion data. Okay, so we look at the first objective, definition, the term empirical and molecular formula. So the definition of empirical formula is a chemical formula that shows the simplest ratio of all elements in a molecule. So for definition of molecular formula, chemical formula that shows the actual number of atoms of each element in a molecule. Okay, so we look at example. Okay, for example, we have butene. So butene, molecular formula of butene is, okay, we have butene. Molecular formula of butene is C4H8. So means that it shows that butene contains, okay, butene contain 4 atoms carbon and 8 atoms hydrogen. Okay, so its empirical formula is CH2. Okay, so why CH2? Okay, why CH2? CH2 is the empirical formula. This is the empirical formula. Okay, empirical formula is formula that shows the simplest ratio of all elements in a molecule. If we take a ratio for carbon and hydrogen inside butene, so we will get CH2. Okay, so this one is C4H8 is we call as molecular formula. Why molecular formula? Because it shows the actual number of atoms of each element in a molecule that made the butene molecule. Okay, so butene molecule contain 4 carbon atom and 8 atom hydrogen. So this is the actual number of each element in butene. So the empirical formula is the simplest ratio of carbon and hydrogen in butene. So CH2. Okay, can you differentiate between molecular formula and empirical formula? So this one is molecular formula, this one is empirical formula. So that is the difference. So the molecular formula of a compound can be determined from the empirical formula if the formula weight or molecular weight is known. Okay, so the formula of molecular formula can be determined if we know the empirical formula if the formula weight or molecular weight is known. So how do we determine the molecular formula from empirical formula? Okay, so we know that the molecular formula of a compound is a multiple of its empirical formula. Okay, molecular formula okay is equals to multiple. Okay, we use integer n here. Okay, multiple of its empirical formula. So if we know the molecular formula weight, so if we know the molecular weight of molecular formula, so weight of molecular formula would be multiple. Okay, if we know the weight of molecular formula, so the molecular formula weight is sum multiply of the empirical formula weight. Okay, Okay, sum multiply of molecular weight. So we use integer n here. So we can calculate the n value. Okay, we may calculate the n value if we know the molecular weight of molecular formula and molecular weight of empirical formula. Okay, so we can calculate the n value. So after we get the n value, we can determine the molecular formula. So we will look at the example after this. Okay, look at the first example. Okay, this one is the determination of empirical and molecular formula from percent of composition data. Okay, how do we solve this question? Okay, so ascorbic acid cures scurvy and may help to prevent the common cold. It is composed of 40.92% of carbon, 4.58% of hydrogen and 54.50% of oxygen by mass. So the molar mass of ascorbic acid is 170 gram per mole. So given here is the percentage of each element that contain in this ascorbic acid. So we know the ascorbic acid contain the ascorbic acid contain 40% of carbon, 4.58% of hydrogen and 54.50% of oxygen. Okay, so we know that the ascorbic acid contain element carbon, hydrogen and oxygen with this percentage. So we need to calculate the empirical formula first. Okay, you need to determine the empirical formula first. And then how to calculate the molecular formula? Okay, so the given molar mass here is for ascorbic acid. So this is the molecular weight for this is the molecular weight for molecular formula. So just now I have told you to determine the molecular formula. If we know the weight of molecular formula, we may determine the integer and the value of integer n. So after that we will know the molecular formula. So first we need to calculate the empirical formula. So how to calculate the empirical formula? We will use the percent of carbon, hydrogen and oxygen here. So how to calculate? First step is to determine the mass of each element in the sample. So do we know the mass of sample here? No, we don't know. So we need to assume, mass of sample, mass of ascorbic acid sample as 100 gram. So that we will know mass of carbon is equals to 40.92 gram. So mass of hydrogen is 4.58 gram. So mass of oxygen is 54.50 gram. So how do we calculate the 40.92, 4.58, 54.5? Okay, so for example for carbon, okay, to get the percentage of 40.92%, so means that mass of carbon divided by mass of sample times 100 equals to 40.92%. So we have assumed mass of sample is 100 gram. So mass of carbon divided by 100 gram times 100, you get 40.92%. So mass of carbon here is so we can cancel 100 here, so leave 40.92 gram. So this is how we get the mass of carbon, 40.92 gram. So this is the same method used to find the mass of hydrogen and mass of oxygen. Okay, so after we get the mass of each element, okay, we will use table that consists of element. The first row is element. So right now our element is carbon, hydrogen and oxygen. Okay, and then mass of carbon we have calculated earlier. Mass of carbon is 40.92 gram. Okay, don't forget to put unit here, gram, for mass of carbon. And then unit of mass, sorry. And then mass of hydrogen is 4.58. And then mass of oxygen is 54.50. Okay, so after that what we need to do is to calculate the number of mole of each element. Okay, unit mole. Okay, don't forget to put unit there. Okay, the unit mole. So how to calculate number of mole from mass? Okay, we know that the formula mass over molar mass. So for carbon 14.92 divided by 12. So you will get 3.41. And then mole of hydrogen is 4.58 divided by 1 equals to 4.58. And then for oxygen, 54.50 divided by its atomic mass is 16. So you will get 3.41. And then after that, you need to calculate the simplest mole ratio. So how to get the simplest mole ratio? You need to divide the number of mole here. Okay, the number of mole you get here with the smallest number of mole. So when we compare these three number of mole, the smallest mole is 3.41. So for carbon, 3.41 divided by 3.41. So you will get 1. For hydrogen, 4.58 divided by the smallest mole is 3.41 equals to 1.3. Okay, and then for this one, 3.41 divided by 3.41 equals to 1. So can we round off? Can we round off the mole ratio 1.3? So we cannot round off 1.3. So we need to multiply the mole ratio with any integers that give you any value that can be round off after that. So for example, so if we multiply the mole ratio with 2, so here we will get 2. This one we will get 2.6. This one we will get 2. You need to try and error. So right now, can 2.6 can we round off the 2.6 to 3? Cannot. We cannot round off it. Okay, so we will try to multiply with other integers. Okay, let's say we multiply with 1.3. We multiply with 3, so we will get here 3. This one, 1.3 times 3, you will get 3.9. And then this one, 1 times 3, you will get 3. So this one, for hydrogen, do you see that our mole ratio is 3.9. So 3.9 can be round off to 4.0. Okay, so that the mole ratio for carbon is C3, and then hydrogen is H4 and O3. Okay, so the empirical formula is C3, H4 and O3. Okay, that is our empirical formula. So to calculate the molecular formula, we know that we know that weight of molecular formula is equals to n weight of empirical formula. Okay, so weight of molecular formula has been given in the question 176 equals to n. So weight of empirical formula, you need to calculate 3 times 12 plus 4 times 1 plus 3 times 16. So you will get n times 88. Okay, n times 88. So value of n 176 divided by 88 equals to 2. So right now you know the integer n is equals to 2. So the molecular formula is equals to n empirical formula. So integer n is 2 times empirical formula C3H4O3. So our molecular formula is 2 times 3 C6. So 2 times 4 H8. 2 times 3 O6. So our molecular formula is C6H8 and O6. So that is how we calculate the empirical and molecular formula from percentage data. So how about combustion data? Okay, how about combustion data? Okay, so for this example, we have a combustion of 0.202 gram of organic sample that contain carbon, hydrogen and oxygen, produce 0.361 gram of carbon dioxide and 0.147 gram of. If the relative molecular mass of the sample is 148, and what is the molecular formula? So right now, given the mass of sample, okay, given mass of sample here 0.202 and mass of carbon dioxide is 0.361 and mass of water is 0.147 gram. Okay, so and then given also the molecular mass is 148 to calculate the molecular formula. So how to calculate the empirical formula first? So right now, same as our percentage data, we need to know the mass of carbon, hydrogen and oxygen in the sample first. So how to calculate? So to calculate number of carbon here, mass of carbon here, you need to know after we burn the organic sample, all the carbon in the organic sample will become carbon dioxide. And for hydrogen, all the hydrogen inside our organic sample will turn to water. Okay, so all carbon and hydrogen is turned to carbon dioxide and water. So we know here, to calculate mass of carbon, we need to use the mass of carbon dioxide that we have obtained. So how to calculate the mass of carbon from carbon dioxide? So we will use the formula. So we will use the formula. So mass of carbon is equals to AR carbon, atomic mass of carbon, divided by molecular mass of CO2 times mass sample. So means that atomic mass of carbon is 12 divided by molecular mass of CO2 is 44 times mass of sample is mass of carbon dioxide, sorry, this one is mass of carbon dioxide. So times mass of carbon dioxide is 0.361 gram. So you will get 0.0985 gram. So and then mass of hydrogen. So we know all hydrogen in our sample will turn to water after we combust. So we know to get the mass of hydrogen, we need to use the mass of water here. So the formula is, since that molecular formula of water is H2O, means that inside water we have two atom hydrogen. So the formula is 2 times relative atomic mass of hydrogen divided by molecular mass of water times mass of water. So you will get 2 times 1 equals to 2. Okay, times 1. 2 means, here means inside water we have 1 atom hydrogen. So you need to times 2. And then molecular mass of water is 18. Okay, times mass of water is 0.147 gram. So you will get the answer is 0.0163 gram. Okay, how to calculate mass of oxygen? Okay. Sorry. How to calculate mass of atom oxygen here? Okay, to calculate mass of oxygen, we can use the mass of carbon dioxide and mass of water here. Why? Because in combustion, you need to combust something, you need oxygen to initiate the combustion. So our oxygen in carbon dioxide and in water may become oxygen from our air. So how to calculate mass of oxygen? So to calculate mass of oxygen, we have mass of sample 0.202, and then we know our sample contain carbon, hydrogen and oxygen. So right now we have to calculate mass of carbon 0.0985, mass of hydrogen is 0.0163. So to calculate mass of oxygen, so we need to subtract mass of carbon and mass of oxygen from the mass of sample. So 0.202 minus 0.0985 minus 0.0163 equals to 0.0872 gram. Okay. So right now we have calculate the mass of carbon, mass of hydrogen and mass of oxygen. So we will use the same table. Okay, right now we know the mass of each element. So our element is carbon, hydrogen and oxygen. So we already know the mass. We have calculate the mass. For carbon is 0.0985. Okay, don't forget to put unit here. And then hydrogen 0.0163. For oxygen 0.0872. So calculate the number of mole of each element. Okay, unit in mole. Okay, so 0.0985 divided by 12, you will get 0.00821. For hydrogen, 0.0163 divided by 1 equals to 0.0163. And for oxygen, 0.0872 divided by 16, you will get 0.00545. Okay. Okay, after that, determine the simplest mole ratio. Okay, simplest mole ratio. Okay, simplest mole ratio, we need to divide our mole that we have calculated earlier with the smallest number of moles. So we compare these three number of moles. Which one is the smallest? The smallest one is 0.00545. So means that 0. For carbon, 0.0821 divided by 0.00545. So you will get 1.5. So for this one, 0.0163 divided by 0.00545 equals to 3. This one, 0.00545 divided by 0.00545 equals to 1. So right now, can we round off the 1.5 value here? Cannot. So you need to multiply with any integer. So we try it first with 2. With integer 2. So let's multiply the simplest mode ratio with 2. So you will get 1.5 times 2 is 3. So you get the whole number. You already get the whole number. So this one, if carbon has multiplied by 2, so all of other element you need to multiply by 2. So this one is become 6. This one is become 2. So we have obtained the whole number for each element. So our empirical formula is C3H6NO2. So how do we determine the molecular formula? Okay, we need to use the molecular formula weight. Okay, so we know that molecular formula weight is equals to N molecule and empirical formula weight. Okay, so molecular formula weight has been given 148 equals to N. Molecular empirical formula weight is 3 times 12 plus hydrogen 6 times 1 plus oxygen 2 times 16. So you will get N times 74. So N is 148 divided by 74 equals to 2. So you know the value of N is 2. So molecular formula is N times empirical formula equals to 2 times C3H6O2. So C3 means carbon. 2 minus 2 times 3 equals to 6. So C6H2 times 6H12, and then 4O. 2 times 2 equals to 4. So we get the molecular formula as C6H12NO4. So that's all for today. Assalamualaikum.